Buffer solution means generally buffer word when we will use. Suppose in a country, suppose any scarcity is there, in that time whatever we stored, that food grains we will use, that is buffer stock, we will say, to maintain the equilibrium. In the hard situation we will use that. That is general example. In our chemistry, buffer solution means the solution which can maintain the pH, same constant pH. That solution is buffer solution. Example, blood is there. Our blood is a buffer solution. Why? Because if you eat some lemon to acid, your blood pH value will be remain same. Suppose your blood pH value is changing, so many biological reactions will be stopped. Because the biological reactions are very sensitive. Those are takes place at a certain pH value. So that's why the pH maintaining is mandatory. Right? Now, how these are maintaining the same pH value? So these buffer solutions are mainly three types: acidic buffer solution, basic, and neutral. Acidic, basic, and neutral. Away, acidic buffer solution ka example, acetic acid, that means weak acid, plus weak acid strong base salt. Weak acid strong base salt. What is that? Sodium acetate. Sodium acetate. This is the acidic buffer. See, common example is this one. One of the example is this. You can take any weak acid, not only this one. Now, basically generally weak base, then weak base strong acid salt. That means ammonium hydroxide is the weak base. The weak base with strong acid like HCl. The forming salt is ammonium chloride. Ammonium chloride. Okay? Then weak acid, weak base. अभी तक हम लिया था weak acid, weak base. That is only CH3COOH plus ammonium hydroxide. Weak acid plus weak base. This is the mechanism here. I am taking acidic buffer solution. The weak acid dissociating partially, acetate ion plus H plus. Then sodium acetate, of course, completely dissociating. Right. These two equations are exist in the given acidic buffer solution. Right. In this solution, suppose small amount of acid if I am adding, then these H plus ions, see here H plus ion, this one also H plus ion, due to this common ion effect, these are combining and forming acetic acid. Combining, forming acetic acid. Therefore, there is no resultant H plus ions increasing in the solution. Suppose पहले 10 molecules था, मैं तो 100 है पहले, ठीक है, I am adding 10 now. Then what will happen? Back side 10 H plus ions going back. अभी कितना बचेगा इधर? 90. You added 10 now. 10 plus 90 again 100. There is no change in the H plus ions. Okay, that's why while we are adding small amount of acid, there is no change in the H plus ion. If there is no change in the H plus ion, there is no change in the pH value. Similarly, if you add small amount of base, that means OH minus ion. This OH minus ion and H plus, these are coming and forming a water molecule. Okay, you may get doubt, sir, H plus ions are consuming. Then H plus ions में कुछ variation होगा? No, because it is getting equilibrium. Suppose same example, पहले 100 H plus ions were there. 10 OH minus ions I added here 10. Then 10 plus 10. So 10 water molecules are forming here. 90 H plus ions will be there. Then immediately this weak acid is dissociating 10 acetic acids are dissociating, it is producing 10 acetate plus 10 H plus. Then 10 plus 90 again becoming 100. Weak acid according to Le Chatelier principle. In the Le Chatelier principle, what we learned? If we remove some quantity from the product, then the equilibrium move forward. If you add something in the product, it will go back. This is the common ion effect. Backwards we are adding product something. Second case we are removing something from the product. So equilibrium moving forward. So always maintaining same number of H plus ions here. The pH will be remain same. This is condition of. This is applicable for only small amount of acid and small amount of base is added to the buffer solution. If you add larger quantity, then obviously pH value will be changed. Right, note down. Next, same acidic buffer I am taking here. Acidic buffer means acetic acid dissociating C into 1 minus alpha, then C alpha. This one we will expect C alpha, then concentration C, sodium acetate, salt. This is completely dissociating. That's why initially this is the initially T equal to 0, then at T equal to at equilibrium. T equal to T dash something. So it's completely dissociate. This concentration is C and C. Right. Now if I apply here Ka, see one thing is this is a common ion effect is there. Common ion effect is there. Due to the common ion effect, what will happen? This is going back. The equilibrium going back. That means it won't be C alpha. See, our expected initially for C alpha tha, if there is no sodium acetate. But here sodium acetate is there, it is producing acetate ion. So due to the common ion effect, it is going back the equilibrium. So that's why ये C alpha तो नहीं होगा. We will calculate that only. Right. Now Ka equal CH3CO minus into H plus upon acetic acid. Right. Now this H plus concentration we don't know. That's only we are going to calculate. H plus concentration equal Ka into CH3COOH, acetic acid upon salt, CH3COO-. Right? This step, clear this step? Right. Now, see acetate ion concentration क्या होगा? This acetate ion concentration is nothing but the salt concentration. कितना salt है उतना ही acetate ion बन रहा है. ठीक है? What about this contribution? This contribution due to the common ion effect it is a decreasing. So it is 0.01 is there, it is a 5 is there. 5 plus 0.01 equal to 5 only. So maximum this acetate ion concentration is equal to, it is a conjugate base only, or it is nothing but, you can write it here, conjugate base equal to salt concentration. Salt concentration. This is the conjugate base, right? Now I am taking logarithm. Minus log H plus equal minus log K minus बाद में log A into B equal log A plus log B log Ka plus log Kb, that means CH3COOH upon acetate CH3COO minus. Right? Now this one equal to pH equal to minus log K equal to pKa, like this, no? Similarly. So this is the pKa, then minus into minus, minus into plus, minus log, this is one of the formula, log CH3COOH upon, this one I can write salt concentration. Salt concentration or I can write conjugate base. इसका नाम है conjugate base और acetate. ये सब तो same है. This is the formula. Sometimes you can find the formula is salt ऊपर, acetic acid down. In that case, here you will get plus. That is only variation. Okay, right. When we will use this formula, for buffer solutions. For buffer solution, right? So this reaction I can write it like this also. pH equal pKa plus log salt concentration upon acid concentration. Salt concentration by acid concentration. So this equation name is Anderson's Hasselbalch equation. Anderson's Hasselbalch equation. इसका कुछ conditions है. It is applicable when while 0.1 or I can say 1/10 से ज़्यादा salt by acid concentration then 10 से कम होना चाहिए. The salt by acid concentrations ratio is hardly 0.1 से 10. ये दोनों के बीच में होना चाहिए. Then only this equation is applicable. Then next topic होगा pH range. Range क्या होगा? pH range. See pH range for these buffer solutions. So least ratio क्या होगा? 1/10. Maximum 10 होगा. So I am taking least. Least में then pH equal pKa plus log the salt by acid concentration least होगा 1/10. Right? 1/10 को I can write 10 power minus 1. That means minus 1. So pKa minus 1. pH equal होगा pH minus 1. It is the lower limit. Upper limit क्या होगा? Maximum case में if I take the pH equal pKa plus log what is the maximum value? 10. Then log 10 equal to 1. So pH equal pKa plus 1. So the pH range is maximum pKa minus 1 to pKa plus 1. मतलब एक वैल्यू चेंज होगा. Suppose X salt is given, X acid whatever is given. इसका pKa value is suppose 5. ठीक है. So ये buffer solution maximum 4 to 6 ये बीच में काम करेगा. This equation is applicable. This solution will act as a buffer solution. Only one pH unit, only one variation. One variation means see one more MCQs question में important है. pH value when it will change one pH equal to one acid is 1 is there, then pH equal to 2 is there. एक HCl solution है. How many times diluted? pH value increasing means diluted हो गया. It is diluted. How many times diluted? pH to increase 1. How many times diluted? 1 time, 2 times, 5 times, 10 times. 10 times diluted. 10 times diluted. Simply here 0.1 m HCl के लिए pH value 1. Then pH 2 0.01. So 0.1 to 0.01 means 10 times diluted. Okay? So 10 times dilute कर सकते. तब वो this equation is applicable, right? Noted. Similarly, for basic buffers, ये POH हो. POH equal pKb plus log salt as the salt concentration upon base concentration. Base concentration. This is the basic buffer solution. Note on this. So buffer range is pKa minus 1 to pKa plus 1. This is the total buffer range. Now here one more point. Which is the best buffer? Best buffer कब होगा? So already we written that salt concentration by acid concentration का वो value कैसे होना चाहिए? 0.1 से 10 in between होना चाहिए. तो best buffer मतलब exactly 1 है तो उधर भी 10 इधर भी 10 उतना तक चेंज कर सकते हैं. So best buffer का ये concentration क्या होना चाहिए? ये ratio क्या होना चाहिए? 1. Okay. So if you take the 1 value, then pH equal to what was the formula? pKa plus log salt by acid. This ratio is, if you are taking 1, then pH equal to pKa. Log 1 equal to 0. Okay. So therefore, here one note point. For best buffer, the pH value will be equal to pKa. For best buffer, the pH value will be equal to pKa. Since salt by acid equal to 1. That much enough. Then already written this step. Next. Suppose, see here, if you are adding some more, see salt by acid, what was the value here? This value is 10. When 10 value, right? 10 value means salt is more, acid is less. Salt is more, acid is less. So salt is more, acid is less, right? So ये कब हो सकता है? This salt is directly which we are adding, right? So here, suppose next here limitation इधर क्या होगा? 0.1. 0.1 का solid by acid concentration 0.1 means what? Acid is more, salt is less. This is the less value, this is the higher value, right? So ये value से dominate कर रहे means acid का concentration is increasing. Acid का concentration increasing. So this becomes total acidic solution. Acidic solution. क्योंकि acid is dominating. ठीक है? Suppose here salt is dominating. Salt is dominating. The salt is not. Salt means actually a conjugate base also we can write. But this conjugate base is not from this acid. This is from external source. From external source. Here when salt is completely dominating means that is nothing but salt hydrolysis. Salt hydrolysis. If this, why we are keeping this is the border, if the value is greater than the 10, then the given solution may hoga salt hydrolysis. If it is less than 1 by 10, that is behaving like acidic solution. ये दोनों के बीच में है, it is behaving like buffer solution. See, 3-3 solution depends on the quantity. Okay? So we will solve one question based on that. So here given that weak acid concentration is given, the dissociation constant also given, then weak acid salt concentration also given. So it looks like a buffer solution. Which buffer this is? Acidic buffer. Then acidic buffer ka pH value formula pH equal pKa plus log salt concentration by acid concentration. Just substitute those values. Ka is this one. What about pKa? pKa equal to minus log Ka. That means minus log Ka means 10 power minus 5. That means 5. Yes. Now pKa is 5 plus log salt concentration 0.2 by acid concentration 0.1. That means 2 by 1. 2 by 1 means log 2 value only. log 2 equal to 0.3. So 5 plus 0.3. That means 5.3. What is this? pH. I'm giving homework question. 0.1 m acetic acid, 200 ml. The Ka value is 10 power minus 4. Then 50 ml of 0.1 m calcium hydroxide. Calcium hydroxide 50 ml, right? Then calculate the pH. Calculate the pH. Okay. See, this is also we can use same, but you have to calculate the concentrations of salt and base. So here formic acid and calcium hydroxide are there; those are reacting, and which concentration will be remain? Just you have to check it from the balancing equation. Then answer will be 4. Once you try it, if you are not getting, then I will explain. pH equal to 4 answer आना चाहिए. Try it.